Tonight, the student Professor Dr. Dolphy Gilpin, and after a relatively lengthy interval, I returned. Here we are once again, and tonight we'll be doing chemistry. And what we did once is that we did the first 20 under the British system, way back there, going up to 1974, which was the ordinary level. I noticed that the chemistry hasn't really changed. We might have been able to do more precision measurement by spectroscopy and telescopy and all the various copy by measurement, but the atomic weight hasn't changed. I mean, the atomic numbers haven't changed for the elements, and the properties of the elements haven't changed. We might have been able to find additional properties, but for the most, 99% remain intact. So I'll be doing the last 20 elements now. First 20 was ascribed to the Caribbean High School and the British, which was the governing system. The Cambridge and London was the governing system. And then we have the American governing system here for the last 20. And so what we have here, I'm going to start from 98, which is Californium, and quickly I'm going to put Californium CF 98 for the atomic number. And I'm doing this from my mental ed here. And likewise, in the 1974, I was able to do all these things mentally from my head. So all of these labs will be done mentally from my head, at least the atomic number and the symbols. But the atomic weights, I mean, I could do some of them mentally, but some of them, if I haven't really, I could do it, but I haven't really taxed my brain with that. But let's do the last 20, California, 98. Einstein, 99. That's the atomic number. My pen is a bit fuzzier, so let me try to get okay, all that is available here are red inks. And so we will use what is tangible. Here I have a blue one over here. All right, let's find a blue one here. So what we have, Californium CF 98 atomic number. And most of these last one would be transitional elements, actinide, and most of them will be actinide. The lanthanide with more the lesser atomic numbers, but let us see. ES, Einstein 99, fermium 100, 101 would be Mendelevium 101. And like I said, we're doing this straight from our head at this time mentally, like as what we did in 1974 for the first 20. Medellium, 101. 102 would be nobelium, NO. 102. 103 would be see put it back here until that come back to my head. 103. 104 would be 103 is Lawrencium, LR. 104 is got there. 104, 105, 106. Sometimes there's a little lapse here called a temporal amnesia at this time. 104. Let's see. 104 is we have 103 Lawrencium. 104 is rutherfordium, I believe. RF. Rutherfordium or rutherfordium. 105 would be 104 here. One of 6 would be seabordium. 107. 108 would be acium. 109. 110 would be Darmstadt, DS. 111 would be RG. I spell it as I pronounce it, Rentigium, Rengium or something like that. It's a very sort of delicate thing to pronounce. Roentgenium, something like that. Rentigium, Rentigium. 111, 112 would be something for magnesium here, another copper, copperusiums. Copperusium. 113 would be neorium. 109 would be micnium. Empty. Micnium. 113 would be meorium, and IH. There's a niobium, which is equivalent to peropium or columbium, which is 41. This one is neorium. Anyway, it's Ni. We're not talking about the spelling now, so it's 113. Not Ni, but NH rather. Ni would be nickel. And 114 would be Moscovium. MC. (116) would be Livornium, LV. 117 would be Tennessine, TS. And 118 would be Og Oganesson, OG. So there we have it. We have 3 missing here. I'm going to try to rock my mentality here to get the root of 40 and 104. 105 would be 106 is Seborgium. 105 would be and 114. Anyway, in the meantime, most of these would be say the last one, I think. We know that 119, they have tried to synthesize that and they have come up with no atoms. 119 and 120, I mean, they have tried that in various laboratories. Even in Japan, they are working on it and they have come up with no atoms. But we are still missing 114, 105. And 107. In the meantime, let's get the modern name for these. What we have here is, okay, at least I could, 107 would be un, nil, septium. And 114 would be un quadrium. At least. And 105 would be un nil pentium. Un nil pentium, un nil septium, and un nil So this would be fermium, that would be 100, un nil, nilium, un nil, unium, un nil, binomium, un nil, trinium, un nil, quadrium, un nil, Pentium, un nil Axiom, un nil Septium, un nil Octium, un nil Enium, and 110, which is down statium. That would be un nilium. Then 111 would be unium, un binium, un tritium, un quadrium, un pentium, un and Og Oganesson, OG, would be un octium. Okay, so there we have it. So the next thing, what we'll do on the next trip, we'll put in now the atomic weights, isotopes, and the electron configuration. And remember, note again that most of these would be artificial elements that cannot stand for long in the atmosphere. They would disintegrate radioactively, most of them. Yeah. The tensine, I got it. Tensine is 117. So what is 105? I mean, we have it as 1 mil pentium. RG and TS. So we have two that is in the modern nomenclature that has not been put into the traditional nomenclature. All right. My brain returned back. This is class 20 USA, and first 20 was carried and British Cambridge. All right, so we'll return and we'll put in the atomic weights and atomic nomenclature, electronic nomenclature.